A deep silence that lasted 40 years has just been broken. And if the warnings are real, a forgotten corner of the United States is in more danger than it ever knew. In September 2024, a mountain shuddered. A swarm of 6 earthquakes, small but unmistakable, rippled through the bedrock of Mount Adams, Washington's largest and most overlooked volcano. For decades, this mountain was a ghost on the seismic charts, producing maybe one locatable earthquake every 2 or 3 years. Then, in a single month, more seismic energy was released here than in the previous 40 years combined. Not a tremor, not a random rumble, a swarm, a pattern. So the United States Geological Survey did something they almost never do. They scrambled. Scientists rushed up the flanks of the mountain, hiking in temporary acoustic sensors and seismic arrays, trying to get a read on a giant that had just opened one eye. Before we go any further, let us know in the comments if you'd even heard of Mount Adams before this video. Be honest. An incredible number of you who watch these stories have forgotten to subscribe. If this is the kind of journalism you value, take 1 second and hit that button. It is the only way we can continue to make these. Let's begin. The real story isn't the earthquakes. The real story is what the earthquakes revealed. When the swarm began, this 12,281-foot high-threat volcano, the second largest in the entire Cascade Range by volume, was being monitored by a single, lonely seismic station. 1. A single point of data on a 70 cubic mile mountain capable of burying entire valleys. It was a data blind spot so profound, so complete, that for decades, nobody even knew what they were missing. Mount Adams was never supposed to be the quiet one. It sits in the heart of the Cascade Volcanic Arc, a 700-mile chain of fire stretching from British Columbia to Northern California. It is a geological sibling to Mount St. Helens, the infamous peak that exploded in 1980, and Mount Rainier, the ice-clad monster that looms over Seattle. Yet Adams remains in their shadow, a forgotten giant. Its native name is Pado, a name given by the Yakima and Klickitat people who have lived in its shadow for millennia. Its English name, Adams, was a mistake. A cartographic error made by a 19th century promoter named Hall J. Kelly in the 1830s. He had intended to name Mount St. Helens after President John Adams, but a slip of the pen on his map placed the name 35 miles to the east, right on top of a massive, unmapped peak. The name stuck. It was the first sign that this mountain's identity was destined to be one of obscurity and accidents. But geology doesn't care about names, and it doesn't care about being forgotten. For hundreds of thousands of years, Mount Adams has been quietly building, erupting, and collapsing. Its earliest rumblings trace back 520,000 years to an ancestral cone called the Hell-Roaring Volcano. The modern peak we see today finished its primary construction around 15,000 years ago, built layer by layer through eruptions of thick, viscous andesite lava. It hasn't had a major explosive eruption in the way we think of them, not like St. Helens. Its last known activity was a series of lava flows and ash falls between 1,000 and 3,800 years ago. An eternity in human terms, a blink in geological time, and that long silence, combined with its less explosive nature, is exactly what has made it so dangerous. It has allowed a threat to build, silently and invisibly, from the inside out. The real danger of Mount Adams isn't an explosion. It's a collapse, and it doesn't require a single tremor or a puff of smoke to begin. For centuries, highly acidic volcanic gases, sulfur dioxide, hydrogen sulfide, carbon dioxide, have been percolating up from the magma chamber deep below. These gases mix with groundwater, creating a potent, corrosive acid. And that acid has been working its way through the mountain's core, dissolving the solid rock that holds it all together. What was once strong, stable, andesite is being chemically cooked, transformed into a substance that geologists describe with a chillingly simple word: clay. Weak, slippery, unstable clay. The mountain is rotting. It is hollowing itself out from within. USGS geologist Tom Pearson has spent his career warning people about this. In his words, that rock has been subjected to hundreds of thousands of years of gases, very acidic gases. The result is a mountain with immense structural weaknesses. Entire flanks of Mount Adams are no longer held together by solid geology, but by the sheer, stubborn friction of rotten rock and the grip of its massive ice cap. And if that friction gives way, the consequences are almost unimaginable. What would you do if you found out the ground under your town was built on a 6,000-year-old disaster? Let us know below. To understand the scale of what could happen, you don't need a computer model. You just need to look at the ground. 6,000 years ago, a massive section of Mount Adams' southern flank let go. An entire wall of the volcano, already weakened by the same acidic rot happening today, collapsed in an instant. It sent 90 million cubic yards of rock, ice, and mud hurtling down the mountain. A lahar, a volcanic mudflow of staggering proportions. It wasn't a slow creep. It was an avalanche of debris moving at highway speeds, a liquid bulldozer scouring the landscape bare. The flow traveled 35 miles down the White Salmon River Valley. It was so immense that when it reached the valley floor, it crashed into a creek and dammed it completely, permanently. The water backed up, flooding the valley behind the debris dam. That blockage, that scar from a prehistoric disaster, is still there today. We call it Trout Lake. The lake itself is a monument to the mountain's destructive power. The evidence is everywhere. The communities of Husum and BZ Corner, Washington, 35 miles downstream from the volcano, sit on top of 65-foot thick deposits from that single event. The entire valley floor is made of the pulverized remains of their nearest upstream neighbor. It is a history written in mud, a warning that has been sitting in plain sight for 6 millennia, largely unread. And it wasn't a one-time event. In 1921, on a clear day with no eruption and no warning, a 5 million cubic yard chunk of rock broke loose from the Avalanche Glacier area on the mountain's southwest side. It cascaded 4 miles down the Salt Creek Valley. It was a fraction of the size of the Trout Lake mudflow, but it was a modern reminder of the same fundamental instability. The mountain is weak. The mountain moves. And that brings us to the town of Trout Lake today, a community of a few hundred people living just 15 miles downstream from the volcano, directly in the path of any future collapse from that same unstable southern flank. If a major debris avalanche were to happen today, triggered by a large earthquake, a minor steam explosion, or just the simple force of gravity finally overcoming the rotten rock, the people of Trout Lake would have between 15 and 20 minutes before a wall of mud, boulders, and uprooted trees arrived. 15 minutes. Not enough time to coordinate. Not enough time to evacuate in any organized way. Enough time to get in your car? Maybe, and find that the roads are already jammed. Tom Pearson's advice is stark and direct. If they hear low-frequency rumbling sounds coming from that direction, we advise folks to get to high ground as soon as possible. It is the most primal form of disaster response. Abandon everything and run uphill. If you have family in the Pacific Northwest, hit the like button and share this story. It's information that could one day be critical. This is the reality of living next to a hydrothermally altered volcano. The threat isn't just about magma. It's about water, acid, gravity, and time. And for 40 years, the official instrumentation designed to listen for those rumbles, to give any warning at all, consisted of a single seismometer. The September 2024 swarm was a wake-up call that nobody in the USGS wanted, but everyone knew was overdue. When John Major, the scientist in charge at the Cascades Volcano Observatory, gave his statement. The language was cautious, precise, and deeply unsettling. At Mount Adams, we typically will see one locatable earthquake, maybe every couple of years, he stated. And this year, we've had 9 earthquakes. During the month of September, we actually had 6 earthquakes. The numbers themselves weren't huge. The largest was a magnitude 2.0, barely strong enough to be felt by a person standing directly on the epicenter. But that wasn't the point. In volcanology, the pattern matters more than the power. 6 earthquakes in 1 month, clustered between 5 and 8 miles deep beneath the summit, was a conversation. Something was happening in the mountain's plumbing. Was it magma moving into a new chamber? Was it water being superheated? Or was it the tectonic stress of the wider region simply finding a weak point? Without more data, they had no way of knowing. The problem was, they had no way of getting more data. The lone seismometer could tell them that the mountain was shaking. It couldn't tell them how. A single station can detect a tremor, but it takes a network of at least 3, preferably more, to triangulate the precise location, depth, and nature of the quake. Without that network, the data was a blurry, one-dimensional shout from the darkness. Was the quake from the east flank or the west? Was it shallow and potentially related to steam, or deep and related to magma? The single station offered no answers. So the USGS and the Pacific Northwest Seismic Network, or PNSN, mobilized. Within weeks, teams were on the ground. They hiked into the rugged, remote terrain of the Yakama Nation Reservation, where much of the volcano lies. They installed temporary broadband seismometers, solar-powered, and designed to detect the faintest of rumbles. They deployed acoustic sensors, microphones capable of hearing the deep, low-frequency sounds of rock fracturing or ice shifting, sounds that precede a collapse. It was a remarkable feat of rapid scientific response. It was also a tacit admission of a massive, long-standing failure. Mount Adams is officially designated by the National Volcano Early Warning System, or NVEWS, as a high-threat volcano. That puts it in the same category as some of the most dangerous and closely watched volcanoes in the country. The threat isn't just about eruption probability. It's an equation that factors in the types of hazards a volcano presents, the size of those hazards, and the number of people and critical infrastructure in the path of those hazards. Adams checks every box. It has an enormous volume of ice on its summit, fuel for catastrophic lahars. It has a well-documented history of flank collapse. It sits just upstream from populated valleys and critical infrastructure. The NVEWS rating was a formal acknowledgement of this danger, and yet the monitoring on the ground was equivalent to that of a low-threat, dormant cinder cone in the middle of nowhere. How does that happen? The answer is a mix of budget priorities, jurisdictional complexity, and simple, human forgetfulness. Mount St. Helens, just 35 miles to the west, gets the lion's share of attention and resources. It earned it in 1980. Its monitoring network is one of the most sophisticated in the world. Mount Rainier, with its direct threat to the Seattle-Tacoma metro area, is also instrumented to the teeth. Adams, the quiet neighbor, the one that hasn't erupted in 1,000 years, was always next on the list. The funding was always a year away. The permitting to install new stations on tribal and Forest Service land was a slow, arduous process. So for decades, the mountain sat in a state of benign neglect. It was Washington's forgotten giant, a stunning backdrop for hikers and campers, a source of spiritual significance for the Yakama Nation, but a low priority for the agencies tasked with watching it. The September 2024 swarm didn't create the danger at Mount Adams. It simply illuminated how long we had been choosing to look away. By July 2026, the seismic swarm had subsided. The mountain went quiet again, returning to its baseline state of 1 or 2 minor adjustments a year. The temporary sensors had done their job, collecting a wealth of new, high-resolution data on the mountain's inner workings. The USGS announced that the alert level remained at normal and the aviation color code at green. For the public, the story was over. The mountain had stirred, then gone back to sleep. But inside the Cascades Volcano Observatory, the work was just beginning. The 2024 swarm provided the undeniable proof needed to fast-track a plan that had been languishing for years. The installation of a permanent, 5-station monitoring network around Mount Adams. The permitting process was accelerated. Funding was reallocated. The scramble to respond to the crisis had morphed into a sustained campaign to finally give this high-threat volcano the respect it deserved. As Seth Moran, another leading scientist at the CVO, has emphasized for years, monitoring is not about prediction. It's about diagnosis. The goal of a modern seismic network isn't to say when a volcano will erupt, but to understand its language. To learn the difference between the small talk of settling rock and the urgent whisper of moving magma. It's about detecting the subtle changes in gas emissions, ground deformation, and seismic energy that are the prelude to every major volcanic event. Without that baseline, you're flying blind. For 40 years, at Mount Adams, we were flying blind. And the new network, once installed, will be listening for more than just eruption precursors. It will be listening for the sound of failure, the microquakes, the tiny fractures, the low-frequency groans of a giant shifting its weight, the sounds that might give the people in Trout Lake not 15 minutes, but maybe an hour, or a day, or a week. In the world of volcanic hazards, time is the only currency that matters. And for the first time, we are finally building the tools to buy a little more of it. The story of Mount Adams is a paradox. It is a story of catastrophic power and profound neglect. A mountain named by accident, ignored by proximity, and now understood through a crisis. The 1,000-year dormancy that made it seem safe is precisely what allowed the internal rot to progress, unseen. The lack of explosive eruptions, which spared it the notoriety of Mount St. Helens only served to mask the more insidious threat of a silent collapse. Every factor that pushed it to the back of our collective consciousness is a factor that has amplified its potential for destruction. Even the efforts to understand it have been strange. In the 1930s, miners used to climb to the 12,000-foot summit crater, braving altitude and thin air not for science, but for profit. They would lower themselves into active fumaroles, vents hissing with acidic volcanic gas, and shovel raw, yellow sulfur into bags. They were mining the volcano's breath, literally chipping away at the evidence of the very process that was dissolving the mountain beneath their feet. The real question is not whether Mount Adams will become active again. It already is. It has been active for 500,000 years. The question is whether we are prepared to listen. The 2024 swarm was a gift. A low-stakes, high-information event that exposed a critical vulnerability in our understanding and our infrastructure without causing any harm. It forced a conversation that should have happened decades ago. I know this is the second time I'm asking, but if you've been watching this long and still haven't subscribed, we're doing something wrong. Hit the button, and I promise not to ask again. Maybe. Now, we have a choice. Do we see the new monitoring network as the solution? Or do we see it as the starting pistol for the real work? Public education, evacuation planning, and a fundamental rethinking of development in valleys built on the rubble of a past catastrophe? The geologists know the truth. The mountain doesn't need to explode to kill. It just needs to shrug. The internal chemistry, the relentless work of acid and water, continues day and night, whether the seismometers are there to record it or not. The rock continues to weaken. The ice on the summit continues to represent a massive, gravitational potential energy, waiting for a trigger. The silence that has now returned to Mount Adams is not the same silence that preceded the swarm. Before, it was the silence of ignorance. Now, it is the silence of anticipation. We are finally listening. But the mountain has been talking for a very long time, and we are just now learning its language. We have drilled into rock, laid cable, and pointed antennas at the sky because a mountain that was ignored for 40 years finally decided to remind us that it was still there. That action, that belated respect, might be the single most important thing that has happened in the White Salmon River Valley in a generation. The new sensors are not a guarantee of safety. They are an admission of risk. They are a tool, but the fate of the people living downstream will not be decided by a sensor. It will be decided by what they do when that sensor sends out its first real warning. The 15-minute clock is still ticking. The hope is